Morning. I hope you're feeling all right after yesterday's adventures. I brought in a couple things that I had over in my office from prior runs on trips similar to what we did yesterday. And I had mentioned that as you move downriver from the Pitt River, you eventually end up in the modern day Lake Britton with its dam. But further downriver, we had this lava dam develop that backed up the Pitt River on the scale of about 2.3, maybe as much as 2.5 million years ago. That valley, that basin, began to fill with water, and part of the result of changing that environment resulted in the development of these big, thick diatomite beds. One of the things that is occurring in that area is there's a plant that's quarrying the diatomite. The plant's called Dicolite, and they quarry the diatomite for all kinds of industrial uses. These little phytoplankton make microshells out of silica dioxide, and these silica dioxide shells essentially have the qualities of glass, and so these microshells, and we're talking on the scale of like a hundredth of a millimeter. So you have to see them under 40 power on the compound microscope and higher. So these guys, observable at 100 mags, 40 power barely, 100 mag is probably best. But they're great abrasive materials, so they get added into industrial braces. But these organisms also have another quality that makes them quite useful, and they make their shells in two halves, but the shells themselves have porous texture to them on each side of the shell. So this might be the upper portion of the shell here, kind of like a petri dish stuck to another petri dish here. And these tiny little pores make them amazing filtering material. And so the diatoms become diatomaceous earth for your pool filter, for example. Well, they go through different processes as they manipulate the diatomaceous earth. Sometimes they heat them just slightly so these little shells stick together and they become packed in filters. One of their industries that taps into this resource is Pepsi-Cola. And they bring all these little microorganisms slightly melted together, and they pack them off to Atlanta. No, that's Coca-Cola in Atlanta. They pack them off to wherever Pepsi is, and they filter all of their soft drinks through diatomaceous earth, which is kind of fun. At the bottom of that succession, commonly as they're scraping and scooping this stuff up, they run into these cool little nodules. These are some of the smaller nodules. And they actually have some big ones too. You crack these things open and there's fossil wood. They've had pine limbs. They showed me a big pine cone in the center of one of these. And with your pine cone kind of sitting in there like this, you know, this big thing, these nodules have growing away from this nucleating center big bladed radiating crystals that essentially define the nodule. And these crystals are of a mineral known as vivianite, which I had mentioned on the bus. It is a hydrated iron phosphate, which is kind of weird. But nonetheless, that's the mineral character. And I have a couple of the nodules broken open up here, and you'll see little pine nuts inside them. They're gorgeous to look at. They're stunning, really. So if you get a chance, check out the vivianite nodules. I also have the Fall River Mills tibia I told you about. You can feel that it is fossilized. It's got a little bit more heft than you'd expect a regular bone to have. So its pore spaces has been filled in with minerals. So a couple little display things. Here's some more fossil wood that we're pretty confident is a portion of a fossil fern from the diatomite deposits at the Dicolite quarry. Rudy, any questions?
The first question, you mentioned the filtering capabilities.
Yes.
What is it that they put inside of the stuff you take hiking and you pull out of the bars?
Yeah.
Would that sort of thing work as well?
I would think that would work really, really well. Not only are these guys tiny, but their little pores are really, really tiny. This is microfiltration capabilities. And I would think that if you had a filter packed with diatomaceous earth, it would be an amazing material strainer. And one of the things you'd have to add to that is a chemical filter, something that's pulling out the dissolved chemicals out of the water. But the particulate matter and probably most of your worries about, you know, giardia and things like that, I bet this could take care of the bulk of that, if not all of it. Yeah, yeah.
My second question is, have you considered taking your lecture and the trip that you took us on and doing it as a geocache?
That would be fun, wouldn't it?
It would
I
be,
would love to do something like that and put it together. I've actually had a whole nother line of thought, and I don't know when I put this into action, but for about 12 years, I'm afraid to say it's been at least that long, maybe longer. I've thought of writing like a series that just really deals with regional geology and takes people out on field trips. And the title would be Stories in Stone, or The Story in Stone. And this would be something like The Story in Stone, Southern Cascades, Lassen, Hat Creek Valley, Fall River, and Fernie Falls. And then maybe a story in stone around Mount Shasta, Wairika, the Northern Klamath, something like that. And within that, it'd be fun to do a geocaching adventure. You could definitely put out CDs that are GPS centered, and so you know you're at that spot, and when you turn and you're looking this way, you've got this view, and here's now the description with that position. I think that'd be really fun. I don't know when I can get that going.
Your spare time.
Right, yeah, exactly.
So if we went to a long-standing freshwater body today, would the bottom be a deep layer of diatoms?
The answer is quite potentially it could be. The conditions on the scale of 2.1 to 2.3 million years ago were perfect for the diatoms. There are freshwater diatoms in Lake Britain right now. And as far as collecting extensive blooms and materials, that's actually not happening. There could be a wide variety of reasons for that. The size of the lake, the dam that was present during this time frame produced a much larger lake than is there now. Agricultural activities upstream could be affecting, you know, the sedimentation rate. It'd be really interesting to core the bottom of the lake and see what's collecting down there. I don't think it's collecting on the scale that it was collecting back then. Yeah.